You've probably heard about prime numbers before, and you've learned how to find factors of numbers before. But today, in today's video, we are going to find the prime factors of any number. First of all, let's review. Let's write the factors of 12. How can we get 12 by multiplying two numbers together? Any two numbers. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And so the factors of 12 are 1, 2, 3, 4, 6, and 12. Now, what is prime factorization? Prime factorization is writing a number as a product of its prime factors. So instead of using any number, we only are going to use the prime numbers when we are factorizing a whole number. So 12, instead of listing the factors as 1, 2, 3, 4, 6, and 12, we are going to write it as something like this: 2 times 2 times 3. You can see that 2 and 3 are prime numbers, and we are multiplying 2 by 2 by 3. They're all prime numbers. And we can rewrite that as 2 squared multiplied by 3. 2 times 2 we can write as 2 squared. And this is how we write prime factors for a number. You may have seen this in factor trees in younger grades, where we took a number and we only used prime numbers to break down another number. The prime numbers that we will use are 2, 3, 5, 7, and 11. So let's take 12, and we would break that down into 2 times 6. But we know that 6 also can be broken down as a multiplication statement as 2 times 3. And so now we are finished, and we have 2 times 2 times 3. We've broken these numbers down into its smallest prime factors, and we write them as 12 equals 2 times 2 times 3. Only using the prime numbers again of 2, 3, 5, 7, and 11, we are going to use a different method to the tree method that we used in younger grades. We are going to draw a line, put 12 on the right-hand side, and we are going to start dividing by the first prime number, which is 2, if we can. We know that 12 is even, and therefore it can be divided by 2 without a remainder. If the number we started off with was not even, we could not use 2. In this case, we will use 2. 12 divided by 2, we'll put the 2 on the left-hand side, and we'll draw a line. 2 into 12 goes 6 times. We write the 6 under the 12. And again, we check, is 6 an even number? It is. And so we can continue dividing by 2. 6 divided by 2 is 3. Now 3 is not even, it's odd. And so 3 can't be divided by 2 without a remainder. So we move to the next prime number, which is 3. 3 can be divided by 3 without a remainder, and so 3 divided by 3 is 1. When we arrive at 1, we are finished. And if you look on the left-hand side now, you see the 2, and the 3. So 12 is equal to 2 multiplied by 2 multiplied by 3. These are the prime factors of 12. Again, we can write this as 2 squared times 3, because 2 times 2 is 2 squared. And so our answer is 2 squared times 3. 12, written as prime factors, is 2 squared times 3. Let's try the number 18. Again, we always have to start with the first prime number, which is 2. Even though 18 can be divided by 3, we will start with 2. Can 18 be divided by 2? 18 is even, and so we can divide by 2. So 18 divided by 2 is 9. Now 9 is an odd number, and so it can't be divided by 2, so we go to the next prime number, which is 3. 3 into 9 goes 3 times. And we stay with 3, and we stay dividing by 3 until we cannot any longer. 3 can be divided by 3 to give us 1, and we are finished. And now we say 18 equals, and we write the numbers starting with the top going down to the bottom. 2 multiplied by 3 multiplied by 3. So 18 has been factorized, prime factorized, as 2 times 3 times 3. And we can rewrite that simpler as 2 times 3 squared, because 3 times 3 is 3 squared. So 18 has been prime factorized to give us 2 times 3 squared. Let's try another number, 30. Is 30 even? Yes, it is, because it ends with 0, and so we can divide by 2. 2 into 30 goes 15 times. Now, 15 is an odd number, and so we can't divide by 2 any longer. So we move to the next prime number in our list, which is 3. Can 3 go into 15? Yes. And so 3 into 15 goes 5 times. Now, can 3 go into 5? No, it can't without a remainder, and so we move to the next prime number, which is 5. 5 into 5 goes once, and anytime we arrive at 1, we are finished. And so 30 equals 2 multiplied by 3 multiplied by 5. 30 has been prime factorized as 2 times 3 times 5. Because we don't have multiple numbers being multiplied by each other, we can't write it any simpler, and so this is our final answer. What about the number 16? 16 is even, so we can start dividing by 2. 2 into 16 goes 8 times. 8 is again even, and so we divide again by 2. 2 into 8 goes 4 times. 4 is still even, and so we can continue dividing by 2. 2 into 4 goes 2 times. 2 is even. 2 divided by 2 is 1. And we're done. So 16 equals 2 times 2 times 2 times 2. Because we have 2 being multiplied by itself several times, we can write this simpler as 2 to the 4th power. And so 16 has been prime factorized as 2 to the 4th power. Just to be sure, let's try 36. 36 is even, so we start with 2. 2 into 36 goes 18 times. 18 is even, so 2 into 18 goes 9 times. 9 is odd, so we can't use 2 anymore, so we move to 3. 3 into 9 goes 3 times. And we keep dividing by 3. 3 into 3 goes once. Now let's write it out. 2 times 2 times 3 times 3. 36 equals 2 times 2 times 3 times 3. And anytime we have a number that is being multiplied by itself more than once, we can rewrite it in index form. And so 36 equals 2 squared multiplied by 3 squared. 2 times 2 is 2 squared. 3 times 3 is 3 squared. So 36 has been prime factorized as 2 squared times 3 squared. Last one. 21. 21 is not an even number, and so I cannot start dividing by 2. So I move down to 3. 3 can go into 21 7 times. 3 can't now go into 7, and so I move down to 5. 5 can't go into 7 without a remainder, and so I move again now down to 7. 7 can go into 7 once, and I'm finished. And when I write my numbers, 21 equals 3 times 7. Since there are no numbers that are multiplied more than once, this is our final answer. 21 prime factorized is 3 times 7. And now it's quiz time. Is this number that I'm about to show you divisible by 2, by 3, by 5, and by 10? You have 5 seconds. 25. Time's up. Can 25 be divided by 2 without a remainder? No, because 25 is an odd number. What about by 3? No, because when we add the digits 2 plus 5, we get 7, and that's not divisible by 3. What about by 5? Yes, because it ends with a 5. What about by 10? No, because 25 does not end with a 0. Question 2. Can this number be divided by 2, 3, 5, or 10? 60. Time's up. By 2, yes, because it is an even number. By 3, yes, because if we add the digits, 6 plus 0 is 6, and 6 can be divided by 3, so 60 can be divided by 3. By 5, yes, because it ends with a 0. By 10? Yes, because it ends with a 0. So 60 is divisible by 2, by 3, by 5, and by 10. Question 3. Is this number divisible by 2, 3, 5, and 10? 21. Time's up. 21 divided by 2? No, because it is odd. What about by 3? Yes, because 2 plus 1 is 3. And 3 can be divided by 3 without a remainder. By 5? No, because it does not end with 5 or 0. By 10? No, because it does not end with 0. And last question. Is this number divisible by 2, 3, 5, or 10? 405. Time's up. By 2? No, because 405 is odd. By 3? Yes, because if we add 4 plus 0 plus 5, we get 9, and 9 is divisible by 3, so 405 is divisible by 3. What about by 5? Yes, because it ends with a 5. What about by 10? No, because it does not end with 0. And now you've solved the mystery of prime factorization and how to break a number down into its prime factors. Fantastic.